Industry 4.0. Industry 4.0 as well as the smart city. For example, self-driving car, a smart manufacturing plant, and intelligent transportation system, smart cooking, smart education, smart safety system, smart lighting system, smart building, smart pavement, etc. The smart cities elements as well as Industry 4.0 is a usage of a high technical, not only the internet system, but also artificial intelligence. The Industry 4.0 is not VR, not AR, not digital factory as well. The internet system is the main spirit of this kind of technical. As using internet to the very end, we have to quote Microsoft Multimedia's Direct Play. In automation, we have CC-Link of Mitsubishi. We have Profibus, CAN-bus, or even CMSCAPP of Germany, while our package of Industry 4.0 CMSCAPP is the same by using Direct Play. The difference is the hierarchy of the structure of data is different. The virtual machine of Industry 4.0 as well as smart city, to draw the geometry, at last we have to use direct graphics of Microsoft Multimedia. As to the face recognition, the fingerprint recognition, the SSY table, the AOI systems, we have to use direct show of Microsoft Multimedia. As to the robot speaking, the voice recognition, the MIDI MP4, the sound of the animal used in video game are using direct audio of Microsoft Media. The direct input including the mouse, the keyboard, and the joystick. These 5 items of Microsoft Multimedia right now is using DirectX 9.0. Although there is DirectX 10, DirectX 11, but the 3D geometry of direct graphics never change. The advantages of Industry 4.0, the CPS, Cyber Physical System, reference 123. The virtual simulation and the physical machine. the virtual simulation to create the virtual machine, which control the physical machine. The response of the physical machine, for example, the encoder response, the input-output response, can be returned from the physical machine to the virtual machine for displaying the geometry model. The next advantage is remote control by server and client linkage by means of IP address. The remote control is the main spirit of Industry 4.0 as well as the smart city. By means of remote control, we can open the air condition before coming home. We can doing the long distance service to save time, save money efficiently. The procedure of the automation. First, we have to define the action. The required actions has to be specified clearly before doing anything. Second, mechanism design. The engineer has to use a CAD system, suppose SolidWorks, to design the mechanism needed for the specified actions. I/O table X defined. The motion control has to define which motor to control which axis. The PLC I/O control has to define the I/O table, which output to control which relay, to switch on which mechanism, from the lower limit to upper limit, to touch which input. The input sensor on will return the signal to the PLC to execute the next step. This is I/O handshake, is widely used in the automation. Fourth, process described. The whole process for automation has to be described step by step. Then, for the fluent running those steps to achieve the machine working automatically. 3 steps of 3D simulation. In Industry 4.0, the 3D simulation has to be done before the physical machine fabrication. The visual script is the new invention of 3D simulations of Industry 4.0. The visual means the movements of the geometry in animation on the screen for the virtual machine. The script is the step of movements. Visual script means you can simulate on the screen before the actual movements of the physical machines. 1. Home position. The machine designed to show the geometry model on the screen in static. That moments to show the home positions. For example, a component driven by an air cylinder, if the home positions is located at the lower limit sensor position, then the lower sensor position showing the home position. As suppose Y3 to push that elements moving up. The elements will moving up and up until the top sensor position. So the home positions specification is the original position of the mechanism. 2. Manual control. Before doing anything, we have to use manual control to test manually each individual axis driven by motion control, and each individual Y output to test the function of air cylinder or hydraulic cylinder, to see if the sensor, if the wire connections correct or not, as well as the input sensor lighting signal is correct or not. After the manual control. 3. Automation. Then we can test to run the machine according to the action script, maybe step by step, maybe several periods of the script running together until the whole visual script can be achieved to run the machine. Then the automations of the machine is finished. Specification. Today we come to here to publish the specification of our system CMSCAPP, not only to Chinese speaking person but also to the English speaking person, actually to the whole world. Before any advanced specification announced in the world, we hope this specification can provide achievements to the user needed for Industry 4.0. The main contents: Scene CSV table. The CSV table is a kind of ASCII written file, each record separated by the comma. As this file opened by Excel, you can see a table-like formats appeared on the screen. Very good for reading and very good for the programming. No matter what scene CSV table opened by CMSCAPP, the 3D geometry will display on the screen. Thereafter, the movement of the individual components to run the action, the physical machine will be needed moving in real time as the simulation. Next, action script CSV table. The action by teaching or by can be specified as an action script. We can feed in the action script by ASCII formats by using CSV style. We named action script by reading alphabet P. P means procedure. The P1 and the P2 until P9 has to be avoided to avoid the confusion with the scene CSV table file. MLS Math Library System Reference 4 for panel control. There is an urgent needed of the user of CMSCAPP, which stated if we don't want to change CMSCAPP program to face the variety of machines to be invented, the control button on the control panel is varied from each other. We need a method to edit the control program to control the different machine. This program is separated from CMSCAPP, which can be edited by the operator of the machine. Then we adopt MLS of Gene Eden to provide this artificial intelligence styled system for the user. The user can learn and write their MLS file for panel control. The action in real time. There are two kinds of motion control or I/O control. The motion control is controlled by motion control card. I/O control is controlled by PLC I/O. The motion control and the I/O control can be exchanged depends on the money, on the time, the cycle time needed. It's very convenient to use in CMSCAPP. The Syn CSV by using FANUC 710 LOBA. There are three important parts. The first one is Syn. The Syn of the LOBA. You can see the X file provide the geometry model of the element of the LOBA. By means of direct graphics, you can see the mesh and object specification. Second is the mechanism. The structure of the LOBA by means of attached to function of direct graphics. We can see the structure of the LOBA. Fn0 is the foundation of the LOBA. Is object 0. The first on the geometry is Fn1.x, which is object 1. The object 1 attached to the foundation object 0. As object 1 moving, the object 0 foundation will not be inflected. The second join Fn2.x is object 2 attached to object 1. The object 1 is object 2's parent. The object 2 is object 1's children. As object 2 moving, the object 1 and the foundation object 0 will not move. While object 1 moving, the object 2 will move as well. This parent and the children's relationship to generate the hierarchy structure of the mechanism. The third part, motion control. The axis 1, 2, 3, 4, 5, 6, 5. The 6 axis of motion control. Car to control the first until the 6th joint of the LOBA. This axis to control the electric motor, and the electric motor drive the physical elements of the LOBA structure. So the third part is important to control, to integrate with the physical mechanism of the LOBA. 4 divisions, 3D model, the tool, the end effector's definition. Limitation. There are 6 axes for the LOBA, so there are 6 specifications of limitation. For example, the upper limit, the lower limit are specified at this position as pivot, Y pivot. The last one, RGB, is red, green, blue arrow. These 3 arrows to show the TCP points of the LOBA, of the end effector. Mechanism 1 of CMSCAPP is the ordinary automation structure. Actually, the whole elements driven by air cylinder or hydraulic cylinder are individual, totally has no relationship with other structure. These elements for PLC is driven by I/O control. The cycle time estimation is most important. For this example, the more assembly machines, the cycle time is 5 seconds. As doing the simulations can estimate the final result of the physical machine. Mechanism 2 of CMSCAPP define the 6-axis robot. This showing the 6-axis moving. Since CMSCAPP is a controller platform, by using CMSCAPP we can use Mechanism 2 to control the 6-axis robot. Mechanism 3 is 6-axis robot as well. The difference is the piston here. This is ABB 7600 robot. Mechanism 4 is 6-axis robot as well. The difference is the rod and wheel. This is ABB 2400 robot. You can use CMSCAPP define this kind of robot by means of Mechanism 4 to control this kind of robot. You cannot use Mechanic 2 to control ABB 2400 robot. Mechanism 5 is SYZ ABC 6-axis polish machine. Mechanism 7 is SYZ AB 5-axis machine. Mechanism 8 is SYZ AC 5-axis machine. As to XYZ BC, let's introduce Mechanism 6. The demonstrations showing a water jet cutting machine. This machine is widely invented and created by our cooperator GAC in Taiwan. This kind of mechanism can be adopted in plasma, in expansion, dispension, in welding, 3D welding system, in laser jet cutting machine as well. Mechanism 13. The first axis up and down, the second axis to control the big arm, the third for the small arm, the fourth for rotating the tool around the y-axis, the z-axis rotating around the z direction. I/O control type 1. This is the new published, invented by CMSCAPP. We come here to publish these tremendous dramatic function for the virtual machine simulations in real time, as well as to control the physical I/O PLC controlled mechanism. The I/O control type 1 is widely used in PLC control. In CSV table, you can see the 2 defined in here means this is the I/O control object. The object geometry model is cc.x. Actually, this is a window of the 3-axis 2 stations water jet cleaning machine. Translocate F feeding 1. This means the type 1 I/O control type 1. The object is cc.x. Z pivot 6 means output number is Y6. As the user in the controller to open the Y6 will move a distance, move the object for a distance minus downward Z N2 downward Z direction 200 millimeters. The moving distance already specified in the scene CSV table already. Thereafter, only the Y6, the button, become red. The simulation, the geometry model 4 will move to minus 2 millimeters position. Let's see the demonstrations. Watch the Y6 on, window down, Y6 off, window up. At the physical machines, the window is driven by 2 air cylinders, controlled by Y6 according to the scene table you already seen. Y6 only on. Immediately the objects will put minus 200 millimeters down to show the final position. The program of CMSCAPP do nothing about the calculation. This is all done by using direct graphics. That's the reason why we say the simulations in real time. In no moments, the window will be placed on the new position. I/O control type 2. For some mechanism supports the end effector gripper to be used of the robot. Suppose the gripper is controlled by 2 fingers. If using I/O control type 1, we need to use 2 output to control the gripper. Suppose the gripper with 3 fingers, we need to use 3 output to control the gripper if using I/O control type 1. So we introduce I/O control type 2 to solve this problem. In here, 2 means I/O control. Translocate 2 means I/O control type 2. The Z pivot output number Y1 in here. That means if output Y1 is on, the N1 9, the actuated object 9, is appear on the screen instead of the object 8 is crossed. What is object 9? The object 9 is GP gripper FG finger cross, CL cross. The object 9 is showing the 3D geometry of a gripper of finger is crossed pose. The beginning 0 means the cross pose is hidden. Only on the Y1 pressed, the object 9 will become appeared, while the gripper finger opened pose, object 8 is hidden. As the Y1 shut, the gripper cross pose will be hidden again. The object finger, gripper finger opened pose will appear. Let's see the demonstration. I/O control tab 2. Watch the Y1 on, the Y1 off. Okay, watch again. The Y1 on, cross. The Y1 off, open. I/O control tab 3. 2 means I/O control. 3 means type 3. The pivot, the driven by output Y3. The N1, N3 means the points to locate the rotating axis. As Y3 be pressed, the mechanism will rotating around axis leading by these points 180 degrees. Let's see the physical demonstration. I/O control tab 3. The Y3 on, rotating 180 degrees. The Y3 off, rotating back, rotating 180 degrees according to these points specified, and this fixed axis perpendicular to this 45 degrees sliding surface. Let's watch again. Y3 off. This mechanism is widely used in loading and unloading of a turning machine. Action CSV, we use part of mold assembly machines for demonstration. A Y10 to push this cylinder down to touch S input 16. As S16 become 1, then open Y11 to move the 3 teeth binding to do the job. As the 3 teeth moving touch the sensor, input sensor 14. The moving will be stopped. Then shut Y11. The 3 T's driven by hydraulic cylinder will retract back until touch the sensor input 13. After the F13 report to the controller, the Y11 be shut. Then the cylinder will retract back to the upper position. The movement will stop until touch the input sensor 15. Okay, let's see how to write the action in CSV table. First, we introduce a function K20. The K20 is to control the input and output of PLC. In direct graphic, the Y and the Z exchange the position. So the line number 3 to show K20 Z10 means shut the Y3 of the machine. Actually K20 is open the PLC. So the line number 3 K20 Z10 means open the Y10 of PLC. The Y10 opened will push the cylinder downward. This moving will keep until touch the input 16. So introduced next instruction K20 at the line 5. The K20 means waiting for the response of the sensor. The which sensor? X16. The input sensor 16 become 1. Then continue for the next instruction in line number 6 and the rest. So after push the mechanism down and X16 become 1, then open Y11 at the line number 7. K20 Z11 means open Y11 to drive the 3 T's moving for binding. The moving will continue until reach the input 14 sensor at the line number 9 K32 X14. As S14 become 1, the program will continue to execute the line number 10 and the rest. After binding, we have continue to open to shut Y11 at the line number 11. Introduce a new instructions K21 to shut the I/O Z11. That means to shut the Y11. Then the 3 T's will moving back until touch the upper sensor input 13 at the line number 14 K32 and line number 13 K32 input 13. As input 13 become 1, the program will continue to execute 14 and the rest. Then we have to shut Y10 At the line number 16, K21, the Z10 means shut. The Y10 will recheck. The cylinder will recheck the mechanism up and up until reach the impulse 15. At the line number 18, K32, X15, as the sensor X15 be reached, become 1. Then the whole operations finished. Let's see the physical demonstration. Action demo. Watch the Y10 and the Y11 on, Y11 off, Y10 off. Let's watch again. Y10 on, moving. Y11 on, moving. Y11 off, moving back. Y10 on, Y10 off, moving back. MLS reference 4. We are adopting MLS from Jim Adams' RPG 2. We still continue use Jim Adams' MLS edit, but we changed the Jim Adams MLA, the template of the action for video game. We defined our new MLA format, the template of Industry 4.0. To use MLS editor, first we have to use load actions to load the MLA of Industry 4.0. Then we can use load script to load a script file from a 5-axis water jet cleaning machine. These MLS files can be edited by the operator based on the control panel of the specified machine. How to write the MLS file? We have to reference the I/O table defined by the user of CMSCAPP. This I/O table is fetched from CMSCAPP. According to the I/O table, we can write the script by MLS editor. To see the first instructions, if DRM1, the first condition of the input 4 equal to truth, that means the input 4 button is pressed. What is input 4 button? S4. And the original is 0, means in water jet cutting modes, as this button S4 pressed by the operator become 1, means thereafter is cleaning mode. Then DO open, one open switch, Y9 is on. What is Y9? Y9 is cleaning mode lamp. We open a Y9 lamp on the control panel to show the state of the machine, means thereafter the machine is used for cleaning, to let the operator understand and to understand thereafter the state of the machine. And if the second if DOM1, the first op condition 9, equal to truth, and the second DOM2, the second op condition 8, equal to false, then that means the first op condition 9 equal to truth means the input 4 is pressed already. Before to open something, we have to check the output button 8 is on or off. Why is output button 8? In here you can see the Y8 is high pressure switch. If on, the high pressure will out. We have to check the Y8 is false, is off, before we do open output Y11. Y11 is for cleaning switch. The cleaning switch is on. The normal pressure water will eject out. So we have to make sure at the very beginning the high pressure is false before open the normal pressure water. If this Y8 is on and open the switch, the high pressure water jet will out. This action may be damage the machine or let the operator injured. After the water cleaning mode on, then we have two choices. The first, to press the S5 buttons to run the cleaning rotating switch on to let the water rotating. The second, to press S6 button to execute the cleaning high pressure switch to let the high pressure water eject out. Let's see an example. If the input first condition Y4 equal to truth and input second condition Y5, the S5 button is truth, the rotating button is pressed, and Y10 is off. Then we do open the output Y3 to let the rotating lamp be lighted first. Then to open output 1, the Y10. The Y10 become on. The cleaning rotating switch is on. Thereafter, the water is rotating. So after these instructions, you can see two lamps is on. One lamp is Y9. The cleaning mode lamp is on. The other is Y3. The rotating lamp is on as well. The user watch these two lamps is on, understands is in the water rotating cleaning modes. The high pressure programs written similar. Arrangement. We already introduced the different mechanism and the different I/O control type. For the physical usage of CMSCAPP, the engineer, according to the action, may be defined a very complicated mechanism for the machines or for the production line. So we have to assemble the machine based on the simple mechanism and the simple PLC I/O. These demonstrations showing to use 3 stations, 3 6-axis motion control car to drive 3 Fanuc 710 robots. The robots usage 80% by teaching. The demonstrations tell the teaching mode to manually control individual robot manually. As to how complicated a machine can be achieved, we come here to announce CMSCAPP spec. You can use operating system Windows XP 32 bits as well as 64 bits, or Windows 7 32 bits or 64 bits, and Windows 8 32 bits or 64 bits as well. Original Industry 4.0 is used DirectX 9.0, which is running in Windows system 32 bits. The CMSCAPP is a practical example. The 32 bits can drive the memory 4 GB as well as 4 GB video buffer. This limited RAM cannot be satisfied by the user of CMSCAPP to design a complicated machine. So we're struggling to solve this problem to adopt CMSCAPP in more memory addressing. At last, we break through the main part of server and client connection by using 64 bits operating system. Thereafter, we can control the memory 8 GB or 16 GB, even 32 GB, the memory of the main or video buffer. For very big production line usage, the station 1 6-axis motion control car of each can control one station. Suppose this station is to control a 6-axis robot. What is each? Each is a industry research organization of Taiwan. Of course, you can use any other motion control car. But in this stage, the CMSCAPP only driven by the motion control car of each. The CMSCAPP allowed to insert 9 6-axis cars inside the controller IPC with PCI slots. For PLC control, CMSCAPP allow the maximum 256 input points and 256 output points up to 9 PLC. That means 9 PLC machines and 9 stations can be mixed up. The maximum is 9 PLC, 9 stations can be controlled by single control platform of CMSCAPP. So you can see how big a production line you can design. But we still to face the physical requirements of the customer. That is the CPU speeds and the GPU's speed and the cycle time of the customer. Up to now, maybe you doubt, oh, you're always talking about CMSCAPP. Oh, your purpose to come here is to sell your controller platform to us to make money. Of course, maybe CMSCAPP is the first or very beginning package of Industry 4.0 in the world. We try to help the customer who have the need of such a big controller for their production. We try to help these kind of customer to find a solution. That's the reason why we come here to publish our CMSCAPP of Industry 4.0 to let the customer make money, and we can make money as well. Everybody glad. But not only this, we still provide open source to anybody of you who have interesting to develop their own controller of Industry 4.0 or widely used this technique in smart city to make big fortune. Before doing any this kind of program writing, we have to adopt a graphic system. In Taiwan, plenty of professors in the university developed the VR support in shipbuilding. Several professors to buy UN from America to do their maneuvering simulation. For one EON package to install one computer, you have to spend 10,000 US dollar. This kind of package, Jing Eden, free to offer game code. After our automation, the game code can be used for Industry 4.0 already. The open source of game code can download from our website, and you can download the mechanism described in previous lecture, and the action script, for example, already launched inside our website. You simply type www.cmsciao.com and press enter at Google. You will immediately into Chiao's automation company to our website. Maybe you don't understand Chinese, but don't worry, you just see Chinese, you just see English, that's all. You just count 1, 2, 3, 4, the first button, and press the first button. The first button says the technical support. After you press the first button, you will enter the technical support pages showing on the screen. You just watch English to see the string RPG demo. And to see the download symbol, and press the symbol and download the compressed file RPG demo. Inside RPG demo, you have plenty of useful information, source code available to use. And as to the graphic, the game code, when you see the game code English, you just find the download symbol and press down the symbol. You will get the game code compressed file. We offer the virtual machine, everything for single station, for single PLC to the maximum 256 input and 256 output. For the physical machine controlled by PLC, you have to use Modbus TCP/IP. Then you have to write your own program to control the physical machine by using the Modbus information. Then you have to download the Modbus. As decompression RPG demo in C drive or D drive or whatever, you will see this file folder. Watch the RPG2. You have the source code of CMSCAPP provided. You have DLL file, you have library file, you have header file of code graphics, and you have DLL library header file of internet, and all necessary files of DLL library header available of CMSCAPP inside RPG2. And in data file folder, you can find the CSV scene table of FINAC 710, the SYZ BC waterjet cutting machine mechanism 6, and the ABB 2400 mechanism 4, ABB 7600 robust mechanism 3, and the specification of action. You can check the action specification to see K20, K21, K32, and plenty of the others specifications of action, of I/O, of ADDC, of the objects, of the attached to whatever. This is VC++ 6.0 run RPG2's demo. RPG2 here opened by Visual Studio VC++ 6.0. Maybe you are expert of IT. You learn plenty of this kind system. But for the ordinary engineer learning mechanical or artificial or naval architecture or aerospace or other engineer departments are not experts about IT. The VC++ 6.0 is strong enough to write any kind of controller. Why we use VC++ 6.0? Because Jim Eden used this program to write down the game code and the video game. We inherit this source code, so we continue to use to run RPG2. Of course, you can open RPG2 by higher level compiler of Visual Studio, suppose 205 version or any higher years version as well, and you can use VC++ 6.0 to translate the class to DLL file, library file, and a header file. Thereafter, you can use C# or Python for the Industry 4.0 program usage. Right now is demonstration to show the mob assembly machine. The static home positions is showing on the screen first for demonstrations, and the Y1 is pressed. This component move up, and the Y1 off, moving down. This is I/O type 1, and the Y10 on, Y10 off. This is I/O control type 2, and showing the data file folder opened. You can see the CSV table of the scene. Right now the P1 RPG is open. The action script is opened in here, and by using run, you see the I/O button is on. The correspondent mechanism will move in position immediately to do the PLC I/O control in real time. This animations demo for your reference after you download the RPG demo. But one thing I have to say, you have to find the VC++ program first to achieve this demonstration. After you download RPG demo, maybe you try to do more research, try to fully understand what the program and how the program to write, to invent your new versions, to control your own machines of Industry 4.0. You try to research, try to study in more advance. Then you can get the free lecture. Only type www.youtube.com. You will into YouTube immediately, and then search Chiao's automation. You will see about 320 YouTube video depicting variety topic to teach not only the DLL output, the CMSCAPP's function, how to debug, how to write down scripts, etc. You don't need to learn from university, from school. You can study by yourself to open a company to make money. I hope your success. Conclusion 1. The script of make the action can be completed before the institutions to simulate the action is to control the mechanical action in real time. 2. Remote control via local area network or wide area network. 3. Script of AI. This 3 is the main spirit of Industry 4.0 as well as Smart City. Reference: E.R. Griefer, Oxford University. CPS. 2. Yongping Dong, Introduction CPS. 3. C. Brooks and E.A.D. UC Berkeley. And 4th, Gene Adams, Programming RPG with DirectX 2nd edition, Premier Press. With thanks for this gentleman's reference. Ending.